Okay, so our next problem, which is a higher order polynomial than 2, is already partly factored for us. So you see it has a 2x plus 1 here times another polynomial. So these polynomials are actually factored. You do not want to expand them out. That would be crazy. So what we do need to do is we need to factor this polynomial some more. So we're going to leave the 2x plus 1 alone, and then we're going to factor the other polynomial. So let's do our our factoring by grouping strategy. 24 is equal to 1 and 24, right? 6 times 4, that's 24, and then 2 and 12, and 3 and 8, and 4 and 6. And what I need from these is I need a difference of 5. So I need to make the products of 8 and 3. So when I go to factor my 6 and my 4, I'm looking to make a product of 8 and a product of 3. Well, the only way I'm going to get a product of 3 is to factor this 6 as a 3 and a 2, right? And then the only way that I'm going to get an 8 from a 3 and a 2 multiplying by something is if I use a 4. So I'm going to put a 4 in here and a 1 in here. So we have a 3 out here and an 8 in here. That gives us my difference of 5. So I need a negative 8 and a positive 3. And you see, that's where I can use my factoring by grouping strategy as not a full-blown strategy to rewrite this middle term and then factor by grouping, but to use it as a jumping off place to get the products that I must create. These are those products that I created with my factors of 6 and 4. And so I'll just write this in there, products to create. And products to create with the factors of 6 and 4 again. So let me write that. I'm going to pause that while I write it. Okay, so products to create with the factors of 6 and 4. Now from there, of course, I'm going to need to set each factor that contains an x equal to 0 and solve. So I have 2x plus 1 is equal to 0, and then 3x minus 4 is equal to 0, and then 2x plus 1 is equal to 0. Now you'll see that 2x plus 1 and 2x plus 1 here and here are the same. I'm going to get the same answer from those. So I don't have to solve this 2 times. I only have to solve it once because I already have it. So no need to solve again is what I'll write here, because once you solve it, it's solved. You know what the factor would be. So in other words, you know, this would be like writing 2x plus 1 quantity squared times 3x minus 4. So here I am going to do solving on this one, giving me 2x is equal to negative 1, and then multiply by the reciprocal, which looks like division because it is, so that I get x is equal to negative 1/2 here. And then here add the 4 to both sides, and then I get 3x is equal to 4, and then I multiply by the reciprocal, which looks like division because it is, and therefore x is equal to 1 1/3, or just 4/3, whichever you like, and it's this or this. And you see, even though this is a higher order equation, we only did get 2 solutions on there. All right, now moving along to our next problems, we're learning how to find the x-intercepts of a parabola. Well, a quadratic equation, an ax squared plus a bx plus a c, is going to give you a graph of a parabola when you actually plot the points. And therefore, when we're finding the x-intercepts of a parabola, what we're finding is when y equals 0, right? Well, when y equals 0, look what that just created. That created a quadratic equation. So finding the x-intercepts is solving a quadratic equation, solving a polynomial equation by factoring. And so we're just going to say 2x plus 1 is equal to 0, and 2x minus 1 is equal to 0. And we'll solve those, and I'm going to do this really, really quickly here because I'm almost out of time and I want to get down to the solution. So x is equal to negative 1/2 here, if you'll allow me the liberty, and x is going to equal to positive 1/2 over here. And what I'm going to do is I'm going to write the ordered